Hello everyone, myself Annapurna R, and today we are going to discuss about the topic dynamic memory allocation using C, malloc and calloc function. So there are four types of dynamic memory allocation functions available in this. They are malloc, calloc, realloc and free. But we are only going to discuss about malloc and calloc function. So before going to the dynamic memory allocation, let's all know about what is memory allocation. Memory allocation is nothing but it is the process of giving some portions of the computer's memory to the programs for their execution. So in simple words, we can tell it's like giving out spaces in a warehouse for storing items. So in programming, memory allocation happens dynamically as your program runs. So when you create variables, your program needs some memory space to store that. So that memory allocation can be managed different ways depending upon the environment. And let's know about types of memory allocation. One is static memory and another one is dynamic memory. So in static memory, what happens is the static memory, it's used for allocating during the time of compile. So in dynamic memory, it is for uh, using at the time of execution, the memory will be allocated. And then in the static memory, as the name suggests, once the memory is allocated, it can't be changed. Okay. And in the dynamic memory, you can always modify the memory allocated. And the static process is a very faster, and in the dynamic, it is a bit slower. So when you go for the example for static memory, you can take as example arrays, and in the dynamic, linked lists are the example. So let's start about malloc function. The malloc function stands for memory allocation, and it is a part of standard library in C. So malloc function in C is used for dynamic memory allocation. Okay. Uh, the syntax for the malloc function here is, here we are assigning a pointer that int star malloc of 5 star size of int, mean the size of this integer should be the size of the all the five integers we are assigning in the memory allocation. And this allocates an array of five integers. Here five integers can be allocated at the same time, and assigns the pointer to point to the first element of this array. I mean, the pointer will go to the first element of this array. And the function of this size is, it specifies the number of bytes to allocate. I mean, example, if this int requires 10 bytes, so that size byte will, I mean, that byte size will be specified in this size, so that malloc function can allocate that number of bytes to that memory. And next, let's study about the return value. Okay. If the allocated memory block is successful, it will return the pointer to the beginning of the allocated memory block. So if it is a fail, it returns a null, indicating that the memory is not allocated successfully, or maybe that can be due to insufficient memory available. Next, the main use of malloc is, like the main use of dynamic memory is, once the assigned memory is no longer needed, you have to eliminate that memory. So that memory can be eliminated using the free function. So memory allocated using malloc should be freed using the free function once it's no longer needed. So the use of this free function is, it prevents the memory leaks and allows the memory to be reused. And once you have allocated the memory and you need an extra memory to be allocated, that can be done using the reallocating memory. So use realloc if you need resize, if you need to resize an already allocated memory of block. So you can add extra memory to the memory allocated in the beginning only. So in simple words, you can tell like this. And let's consider an example to know a bit more about the malloc function. Okay, so first include standard io.h and the standard library.h. So here we are defining a main function int main, where we are declaring a pointer array arr. So the array here we are initializing that array to int star malloc of 5 star size of int. So here this allocates memory for 5 integers. Okay, so the 5 integers memory will be allocated in this step. Okay, so after this, what if there is no sufficient memory? So that means the handling the failure process. So for that, if of array is equal to null, print memory allocation failed and return 1, return from the main indicating failure. So for failure we are returning 1, telling a printf statement memory allocation failed. Okay, so if it is not a null, if it is not equal to null, what can be done? So using the allocated memory, for that we are using a for loop where integer I is set to 0 and until less than 5 it has to be uh, taken, and then iteration should be increased until it is less than 5. This condition is satisfied. So array of I can be anything. It can be I can be anything, but it should be less than 5 number. So array of I is equal to I star 2. So here the allocation process goes on, and the close of for loop takes place. And now after allocating the if any extra memory is present, we have to eliminate it by using the free. We have to free that memory extra allocated by using the free of array function. So the extra allocated memory is removed and return 0, telling that a success has, return from main indicating success, that allocation has been successfully done. To tell that, return 0 we are using. So this is the example for malloc function. I hope you understood it well using this example. Next comes calloc function. Here calloc stands for contiguous allocation. Uh, Here the main difference between the malloc and calloc is, in the malloc we are assigning memory to one array or some memory, but here in the calloc function we are allocating memory to blocks of memory. I mean, uh, it like a huge number of memory is being assigned to some array. It can be array or else like anything object. uh, it is used to allocate a specified number of blocks of memory, each of specified size, and initializes all bytes to 0. And the main thing in the calloc function is it initializes all bytes to 0. So that is the main difference between the malloc and the calloc. And the syntax for the calloc function is void star calloc of size t num elements and size t element size, where num elements is nothing but number of elements to allocate memory for. Example, you can take number of elements as 5, and element size of each element in bytes. I mean, the element size could be any bytes, 8 bytes, 10 bytes, it could be any bytes. So this is the element size to specify in the syntax. Now, it is particularly useful when you need to allocate memory for a collection of elements such as an array and initialize all the allocated memory to 0. So, now come to the return value. If memory allocation is successful, that means calloc returns a pointer to the allocated memory block, not to the beginning block, but to the allocated memory block. If it is a failure, then it returns a null. The failure could be due to the insufficient memory. Now comes the initialization. Unlike malloc, which allocates uninitialized memory, calloc initializes the allocated memory to 0 for all bytes. Unlike malloc, the calloc will not allocate the uninitialized memory. It only allocates the initialized memory, that too it initializes 0 for all bytes. And next comes when to use calloc. So you might be thinking, when to use this calloc? So use calloc when you need a memory block that is initialized to 0. This is common when working with arrays or data structures that require a predictable starting state. But if 0 initialization is not required, the performance is critical, malloc could be a better choice. So you can go with malloc if you don't want it to initialize to 0. So now let's consider a example for calloc. Include stdio.h and standard library.h main function. Here I'm defining pointer array, and int, it is integer, number of elements is 5. So here allocate memory for 5 integers. 5 integers could be allocated in this line, and array is equal to int star uh, calloc of num elements comma size of int. Num elements is nothing but 5. So the size of that is 5 times the size of one integer. If of array is equal to null, to handle the failure, we are using a printf statement, memory allocation failed, and it returns 1 for failure. For success, it is returning 0. And to use the allocated memory, we are using a for loop where integer I is set to 0 and I should be less than num elements, which is nothing but 5, and it should happen increment to up to less than num elements. So printf statement is taken to print the values which are less than num elements, and a percent d, it is integer, and array of I, it could be array of 0 1 2. You can take like that. Outputs will be 5 outputs will be displayed. And next, to free the allocated memory, when it is done, we are using free of array and return 0 for success and close the parenthesis. This is the example of calloc function. I hope you understood better in this example. Now we are going for applications of dynamic memory allocation. Dynamic memory allocation has variety of applications such as data structures and algorithm, file processing, graphics and multimedia. Where in data structures we are using it for arrays and linked lists, for arrays to be resized as needed, and for linked list, nodes and linked lists are dynamically allocated and linked together, enabling dynamic size adjustments and efficient memory usage. In the file processing, buffering and parsing we are using for reading and processing files of unknown size, and for parsing structured data from files and streams, we are using dynamic memory for flexible handling of variable data sizes. And in the graphics and multimedia, image processing and video streaming, where uh, dynamic allocation is used to manage memory for image data, allowing it for manipulation and processing of different sizes and formats. And in video streaming, buffers for video frames are dynamically allocated to store and use efficiently during streaming. And network packet buffering and embedded systems resource constrained environments, we are using dynamic memory, where it allows the network systems to handle incoming and outgoing packets efficiently, means it should not be collapsed, and especially in the scenarios with variable packet sizes. And embedded systems where memory resources are limited, dynamic allocation helps in efficient memory management without wasting the spaces. And now let's know about the benefits of dynamic memory, where it is a flexible, efficient, scalability and performance. The flexibility, because of managing of varying data sizes and structures, it is flexible, and it improves the memory usage by allocating memory only when needed and releasing it when no longer required, so it is efficient. And scalability, it supports applications that need to scale dynamically based on user output, user input and external factors. So that is how it is supporting applications. And now comes the performance, enables optimized memory usage and faster execution. So the performance is very good for dynamic memory allocation. Challenges and considerations, memory leaks, fragmentation, and complexity. These are all the disadvantages of dynamic memory, where improper handling of dynamic memory can lead to memory leaks. if memory is not deallocated properly. So you need to handle it very in a proper way. And next, fragmentation. Frequent allocation and deallocation can lead to memory fragmentation, affecting the overall performance over time. And next is it is a complex thing, so it requires a careful management to ensure efficient use of memory and to avoid bugs related to uninitialized or improperly managed memory. So these are all the disadvantages of dynamic memory allocations. And so when it in total summary, I can tell dynamic memory allocation is essential in a wide range of applications where flexibility, efficiency, scalability are critical. It enables developers to create robust software that can handle varying data sizes and adapt to changing demands effectively. So I can tell dynamic memory allocation is a very useful thing in this modern world due to its flexibility, efficiency, and scalability. But a very small precautions has to be taken while using it so that you can get the most useful out of it. And however, proper understanding and careful management are necessary to mitigate potential pitfalls associated with memory allocation and deallocations. So thank you everyone for watching this video. I hope you find this video helpful. Thank you.